For this next example, and the last one we did, and this one here came straight out of our textbook, so will the next one. So if you want to dig through and see these, I didn't make up these numbers. So in the 111th Congress, there are 41 Republicans, 2 Independents, and 57 Democrats, or there were when this book was written. We're making a new committee, and we want to select 3 senators from this list. Okay, the probabilities that we want to find, we want to find the probability that all of them, all 3 will be Republicans, the probability that all 3 will be Democrats, the probability that 1 candidate will be chosen from each party, meaning 1 Republican, 1 Democrat, and 1 Independent. I'll help you set up the first one, and then you can try the other 2 from there. If we want the probability that all 3 of them will be Republicans, on the top, what we need is the total number of ways I can choose 3 Republicans. And on the bottom, we need to write the total number of ways we can choose 3 people from this list. So from the Republicans, there are 41 of them, and I want to choose 3 of them. Now on the bottom, I'm still choosing 3, but I'm choosing 3 from the grand total of people that we're starting with. So 41 and 2 is 43, there's 51, there's 100 people that I'm choosing from to start with. So 41, choose 3. I'm going to let you guys play with that actually for a minute at your desk, and pause the video, and when you turn it back on, the work will be here. Okay, numbers are a little bit bigger here, but still very doable if you break them down. Okay, that's a 4 instead of a 9. So 41, choose 3, means I have 41, 40, 39 on top, and I have 3, 2, 1 on the bottom. We can either reduce, or you can, those are doable numbers on your calculator, but you should get 10, 6, 60. On the bottom, 100, choose 3. You have 100 times 99 times 98, and everything from 97 and down goes away right here. And then 3, 2, 1. And you don't have to take the 2 out of the 100, you can take it out of the 98, but if you clean that up, you get 161,700. On these, you do not have to leave them as a fraction in lowest terms. To 3 decimal places, if I can squeeze it in, you get 0.0066, 0659. That's what my calculator says. All right, so the nice thing about these is, regardless of how I tell you I want the committee to be made up, on the bottom we're still choosing 3 people out of the 100 that we started with. So that 161,700 will be the denominator on these 2 parts as well. You just have to figure out how to put those numerators together. So go ahead and try the Democrat one. When you're ready, unpause it. We'll talk through it real quickly, and then you can pause it again to do the last one. Okay. So probability of 3 Democrats is out of 57, we're choosing 3 of them. If you do the work off to the side, I didn't write it down this time, but you should get 29,260. And again, the denominator will be the same as it was before. To 3 decimal places, you get 0.181. I'm going to set up the next one, pause it, and see if you can get there. But then I am going to do this one in 2 bites instead of just 1. So I'll help you along the way if you get stuck once you get started. Pause it and see what you can do. Okay, so if we want one of each, and I went out of order, I just went the way they were written across the top up here. But out of 41 Democrats, we want one of them. Out of 2 independents, we want one of them. Out of 57 is what that's supposed to say. 57 Democrats, we want one of them. And if we multiply those 3 together, that's what goes on top with the regular denominator that we've been using. Go ahead and pause it again if you need some time to compute what those 3 things are. They're pretty short and sweet, but figure those out, and then round to the nearest thousandth like we've been doing. If I have 41 people and I'm only choosing one of them, there's 41 ways to do that, and only 2 ways to do this, and only 57 from there. If We multiply those together and divide by this, we get 0.029. Just less than a 3% chance that it would be made up that way. Next example, holly plants. They apparently have gender, and you have to plant a male and a female plant close enough together that they can pollinate and create berries. If you want berries on your plant. So the store has 12 of them, and they don't have them marked. They know that 8 of them are female, but they lost the tags which ones are what. So somebody's going to buy 3 plants. Just grab 3 of them off the shelf, and we want to know the probability that berries will be produced, that we'll have at least 1 male and 1 female plant in that group. So I'm going to let you pause it and play with it for a minute or two and see what you can think of, and then come back when you want to know more. One way that we can make sure we end up with berries is if we have 1 male and 2 female plants, and so we should be able to figure out that probability. But also, there's another possibility here. If 2 of the plants are male and 1 of them is female, we'll also still get berries on our plants once we get them put in the ground. So there's 2 different probabilities that we're going to get to figure here. And then once we've done that, using the formulas that we used on these other 2 pages, once we've done that, what do we do to the 2 probabilities here? Think about that. So see what you can get done at your desk to find each one of these guys separately. And then think about what you need to do with both of those numbers to get the final answer when you're done. If we want 1 male and 2 female plants, it tells us 8 of the plants. We don't know which 8 are female, but we know 8 of them are. So if 8 of them are female, that means 4 of them are male. So choosing 1 from the 4 male plants and 2 from the 8 female plants. On the bottom, we're choosing 3 of the 12 total plants. Okay, so 4 times 28 is 56. Maybe 112 over 220. Alright, so if you didn't get the 2 male and 1 female plant figured out, maybe this will be a good example for you. Up above, you can use that kind of as a template. See if you can get the probability of taking home 2 male and 1 female plant. So 4 choose 2 is 6, and 8 choose 1 is 8, and we still have that 220 on the bottom for 48 out of 220. And both of these reduce. We could do that, or we could wait, because I know that for either of these 2 situations, I'm going to meet my goal, and my goal is that I'm going to end up with berries on my plants when the time comes. So remember with our tree diagrams earlier on, we said if more than 1 branch of that tree gets us the event that we want, then once we find the probability of each branch, then we add those 2 numbers together. Okay, so 1, 12, 20, that looks like 160 over 220, hopefully, and as a decimal to 3 decimal places, we get actually it's 0.72 repeating. So to 3 decimal places, it'll be 0.727. Okay, we've got, if I just grab 3 plants at random off that shelf there at Home Depot or wherever I am, okay, at the nursery, we grab 3 plants out of the 12 that are there. I've got a 73% chance almost of coming home with enough male and female combinations that I should get berries on my plant. So give me a shout if you have trouble with these or other questions like it from your book. Get a hold of me, please.